Welcome back, everyone. In this video, I'll cover the processes section of the 12-factor app. Let's get started. So the processes section starts with execute the app as one or more stateless processes. The app is executed in the execution environment as one or more processes. Okay. So basically, they're saying the app will be executed as one or more processes. In the simplest case, the code is a standalone script. The execution environment is a developer's local laptop with an installed language runtime, and the process is launched via the command line. So in the simplest case, they're saying the code is a standalone script. The execution environment is a developer's local laptop with an installed language runtime, and the process is launched via a command line. Okay, so if you have a simple script that is in your version control system, this itself can be considered an app, a 12-factor app, at the simplest case. On the other end of the script, on the other end of the spectrum, a production deploy of a sophisticated app may use many process types instantiated into 0 or more running processes. So on the other end of the spectrum, they're saying a production deploy of a sophisticated app may use many process types, instantiate 0 or more running processes. Okay, 12-factor processes are stateless and share nothing. Okay, so a 12-factor processes are stateless and share nothing. So they don't share, they don't store anything about, let's say the application state or the user's state is not maintained within the application, is what they're saying. Any data that needs to persist must be stored in a stateful backing service, typically a database. This is the most important part of the processes. So basically, they're saying a 12-factor process is a stateless process, and they share nothing. Anything that needs to be stored will be persisted in a backend database. So the memory space or file system of the process can be used as a brief single transaction cache. That's saying, this says that the memory space or file system of the process can be used briefly for a single transaction cache. You shouldn't be storing any state in the file system or the memory space allocated for the app itself. For example, downloading a large file, operating on it, and storing the results of the operation in the database. The 12-factor app never assumes that anything cached in memory or on disk will be available on a future request or job. So this means the 12-factor app does not assume that anything that's in memory or on the disk will be available for a future request. So let's say you have you have the app running, and you're putting something into its memory, let's say a counter. So whenever the user visits or whenever the user clicks a like button, you keep a count of it in memory so that the increment function can be done much faster. So if for whatever reason you shut down the app and come back in, you cannot expect, let's say you clicked on likes 5 times. So in the memory, there is a counter which is set at 5. When you come back, you cannot expect the app to go to its memory and find that 5 still there. So it should be persisted in a backing service such as a database. With many processes of each type running, chances are high that a future request will be served by a different process. Yeah, so one of the reasons they don't want to maintain state is because there could end up being many processes running, and the user's request could end up going to a different process. So let's say the user, we have 5 processes out there, and the user went to the first process, and the next call could end up going to the second process because everything is done statelessly. So that's the reason why in a 12-factor app doesn't want to maintain state within the process. Even when only one process, a restart, will usually wipe out all local state. Yeah. So even if you have one process, the counter example we talked about, even if you have one process, yeah, everything can be wiped out. So you should not maintain state. Asset packagers such as Jamit or Django compressor use the file system as a cache for compiled assets. A 12-factor app prefers to do this compiling during the build stage, such as the Rails asset pipeline, rather than at runtime. So looks like some asset packages, I haven't used Jamit or Django compressor, use the file system as a cache for compiled assets. So a 12-factor app prefers not doing this, and they want to, in a typical 12-factor app, they want to do something like this at the build stage. Some web systems rely on sticky sessions. This is caching user session data in memory of the app's process and expecting future requests from the same visitor to be routed to the same process. Sticky sessions are a violation of 12-factor and should never be used or relied on. For a 12-factor app, the 12-factor apps should not be using sticky sessions, is the bottom line. Session state data is a good candidate for a data store that offers time expiration, such as Memcached or Redis. Okay. So 12, if you want to store session state, 12-factor app recommends a session state to be stored in a Memcached database or a Redis database. So at a high level, this section talks about making sure your processes are stateless, so that when there are multiple processes, the calls that go for, if the first call goes to the first process and the second call goes to a second process, there is no dependency. So they want to make sure your processes are stateless. If you want to store session data, the recommended approach is use Memcache with some kind of a time expiration, or Redis database with some kind of time expiration. And if you have to store state, that's a 12-factor app recommends you store the state in a data store, a backing service like a database to store the state. Yep. Again, to summarize, 12-factor app processes are stateless and share nothing. Bottom line. Let's go to the next one. The next one is port binding. I'll stop this video and go to the next one. I'll do another video for port binding.